Yesterday we discussed about pressure, and today we'll be talking about density, of course. So I have got a couple of experiments today as well. We'll be talking about the density. When we are talking about the density, of course, we'll talk about Archimedes Principle and also the law of flotation, and few terms like mass, volume, upthrust, and so other terms. Let's begin. So to begin with, I'm showing you one picture over there. Can you connect with the laptop, sir? Okay, what is this? This is a cruise which is known as the Symphony of the Seas. And do you know that this is one of the largest and the biggest cruise of the world? Do you know what is the weight of this ship? Its weight is 228081 gross ton, and it can harbor about 6,680 passengers. And what about the length and the height? 361 meters length and 65.7 meters height. Now the question is, how can a ship like such a gigantic mass and tremendous volume, space in shape and size could float into the water? That is the question for today. If we see, and suppose if this is a metal, this is the water, metal, when kept into the water, it sinks. It sinks. Simple experiment. This is water, metal. When it kept into the water, it sinks. But the same ship, that enormous big ship, how could it float into the water? That is the question for today. Can you guess why? Let me have one experiment here. I have got the aluminum foil. This is the aluminum foil. Let me tear it. So again, this foil, I'm taking a glass now. What do you think? This is a metal, in fact. Aluminum is a type of metal. What do you think? Will it sink or will it float? Let's check. Oh, sorry. Let's check. Okay, it floats. It floated. You could see here. This is the metal, but it floats. So what can I do so that it will sink then? So this is having a bigger volume. Now I'm going to squeeze it. Squeeze it like this. Squeeze it, squeeze it. Let's check now. Yeah, it sank. Did it? Yes. It's at the bottom here. You could see it sank. What is the reason? The same aluminum foil, just if I make of this size, suppose some like a cup or a boat shape, I'm making it like this. Here it floated. So this I made it like the boat shape. It floated over here. Now this same boat, I crossed it, squeezed it. Now let's check. What would happen if I keep it into the water now? It sank. You could say it sank. The question is why? Why did it happen? Same material, same mass, same weight. But in one of the experiment, it floated in the water, while in the second one, it sank down. What could be the reason? This is the question for today. Let me speak a story. Let me share one story. Let's connect with the laptop. Do you know this person? Of course, it is Archimedes. Now, there is a story of Archimedes. Before I go with the story of Archimedes, let me ask you one question. Sandeep sir, what do you think? Which is, sometimes it makes me laugh, sorry. 1 kg cotton and 1 kg iron. Which one is heavier? Yeah, it's same. 1 kg cotton and 1 kg iron. Which one is heavier? So it's same, equal, because both are 1 kg. That's right. Both are 1 kg. So both are 1 kg, 1 kg iron and 1 kg cotton. Both are equal. But what about the volume then? Maybe 1 kg iron is like this space, weighing like dog, we have seen it. And 1 kg cotton may be like this much amount. Look at the volume. The volume is different. Though they have the same weight, the volumes are different. So what does it mean? So I will use a board just to show the concept of density and mass. Can you show here? So what we said, it's 1 kg, 1 kg, both are 1 kg. This is iron and it's cotton. Both are 1 kg. So if you look at the weight is both 1 kg, 1 kg. So weight, we know weight equals to mg, that g and g is same. So mass are equal. But what is different here? Suppose 1 kg cotton may be of this much amount. This could be cotton. And 1 kg iron could be, suppose, this much only. This could be iron. Now look at the volume. Difference is the volume. Difference is the volume. So what we could see now? So over here, the mass, the substances contained in it is less compared to the volume. So that means that gives us the concept of density. So density is mass by volume. So what I mean to say is that from this figure, what we come to know is that the density of cotton is very, very less compared to the density of iron, though they have same mass, because weight is 1 kg, 1 kg. Both of them have 1 kg weight, which means their mass is same. But what differs here is the volume, and because of the volume, their density also varies. Now we are very clear that iron has higher density than the cotton. So we are clear now. Iron has higher density than the cotton. So we are talking about the density and few more things. So let's connect with the story again. I spoke you about the Archimedes. So there is one, I have shown you one figure there. This is Archimedes. A story, let me tell you the story now. So it's said that in Greece, King Hero II, he ordered for a golden crown. Suppose some amount of gold was given to the goldsmith, and it was made, the crown was made. When the crown is brought back to the king suspected that it is not purely made of the gold. Like the king had the suspicion that the goldsmith might have mixed some other metals. Though the weight is the same, but the king suspected that the goldsmith might have cheated and it is not completely made of gold. So he asked the people to check the purity of that crown, whether it is completely made of gold or not. So in that case, the task is given to the Archimedes. So Archimedes tried to think what to do, how to find the purity of the gold. He did not have any idea. One day, what happened is that as he was about to take a bath in a bathtub, the bathtub, for example, suppose this is completely filled with water now. Let's assume that it is the bathtub. It is completely filled with water. As the bathtub was completely filled with water, when Archimedes went into the tub, what happened? Let's check it. Suppose this is a person. When you keep something over here, okay, some water spilled out. You could see water spill out, extra water spilled out. So what is the reason? Archimedes got the idea from this one, that something knowledge he generated from there. The story says that then he ran into the street and saying, "Eureka, Eureka, oh, I have got it, I have got it." Sorry. So with this one, he came to one principle known as the Archimedes Principle. So how did he find the purity of the gold then? What he did is that he put the gold into the water and found the displaced water. What is the weight amount of the displaced water? And he kept the crown, that one, and the amount of water displaced was higher than the pure gold. So this proved that the crown did not contain the pure gold. This is how he explained. So that's why from this experiment today we got to know one very important principle that is known as the Archimedes Principle. And do we know that Archimedes Principle is applied in lots of things? For example, ships. I showed you. The flotation of those gigantic ships happened because of the Archimedes Principle. Even the submarines, they run because of the Archimedes Principle. Even the hot air balloons, that is because of the Archimedes Principle. And nowadays, that Archimedes Principle is also applied in medicine and other sectors as well. Might be wondering how it is applied in medicine. So to know more, let's ask some more questions to ourselves and go with the Google or the YouTube. I suppose we all can do that. Now going back to the story, Archimedes formulated one principle then. So it's very simple. What he told us is that the weight of water displaced is equal to the mass or the volume of the body. That means the weight of the body. This is a simple principle given by the Archimedes. And using this principle now, we are having few experiments. Please remember, this principle is very important. And it is very simple. It's very, very simple, which says that when any object is immersed into the liquid, fluid, then it displaces some liquid, which is equal to the weight of the object. Very simple. That is equal to the weight of the object. So the question now, I showed you the ship at the beginning. That is the biggest ship of the world, Symphony of the Seas. Let me show you the ship again. This is the ship, the biggest ship of the world. And its weight is 228,081 gross tons. Let's suppose, how much water do you think the ship has to displace so that it can float into the sea? Or very simple, suppose I am now 80 kg. If I find my weight equals to mg, so 80 into 9.8, let's suppose 10, I am 800 Newton. My weight is 800 Newton. Suppose if I have to float in the water, how much water should I displace so that I can float? I give you the options. 600 Newton, 700 Newton, 800 Newton. What do you think? How much water should I displace so that I could float in water? And my weight is suppose 800 Newton. Yes, you're right. The answer is 800 Newton because Archimedes mentioned that the weight of the body is equal to the weight of water displaced, and that results to the upthrust. So if I want to float into the water and if my weight is 800 Newton, and of course the water displaced should be 800 Newton, and if it is less than 800 Newton, then definitely I'm going to sink. This is very, very simple experiment done by Archimedes, and this is very, of course, a very important, significant knowledge given by Archimedes in our science world today. Now using this one, we got the concept of density also. Density, I told you, with the example of 1 kg cotton and 1 kg iron. 1 kg cotton, 1 kg iron. Both are 1 kg. So their mass is 1 kg, 1 kg. Right? So, weight 1 kg, actually this is 1 Newton. Both mass is 1 kg. Now, which means that their mass is the same. What differs of the iron and the cotton, I said? Cotton occupies bigger space, so the volume is more. But remember, their mass is same, means the number of matter in them is same. So bigger space, can I draw one figure again here? So if we take the equal amount of space, suppose, if this upper one is the iron, iron may have the particles very dense like this, whereas cotton maybe have the particles sparsely distributed in that way, which means this cotton has less density, whereas this iron has more density. Just to show you in the form of the figure also, trying to mention you that the concept of density. So we are clear now. Density is definition we can create. What is the definition of density? Density is the amount of matter contained in the given volume, in the given space. Or if you go with exact formula, then density equals to mass upon volume, so which can be defined as density is mass per unit volume, the amount of substance contained in a body in a unit volume. We could say in that way. And of course its unit would be mass is kg, volume is meter cube, mass per meter cube. Now we are not going with these content parts. Please go through the book by yourself, learn the definitions and units, all those things by yourself. Today I'm going to show you some of the experiments that is related with density and Archimedes principle. So the first experiment I performed over here, I took the foil, this is the aluminum foil, and that aluminum foil was kept into the water. For example, again let me repeat. So this is the aluminum foil. If you keep into the water, now this is floating. You could see here, this is the aluminum foil, it is floating. Why did it float? Question. This is the one. And same aluminum foil, now it is occupying more volume because it has bigger space occupying. Now I am squeezing it, folding it. Now it is occupying less space. So its volume is decreased now. Same mass, remember, this is the same mass, same substance, but its volume is now decreased. So when the volume is decreased, what will happen? The density will increase. Same mass, volume decrease, density is increased. Now what would happen? Let's check. Now I'm keeping this into the water. Is it visible, sir? Oh, it's again floating. It's not sinking. That means again, this has to be squeezed so that the density would be higher than what we wanted to make. So it's not hygienic. Actually the water is distilled water, so everything I have washed my hand with soap and everything, so I can just bite it, just to squeeze it. Let me try with my hand first. I'm not being hygienic, sorry. Let me try once again. So this one, I'm just squeezing it with my nail. I do not have the nail. In the second episode, I trimmed my nail as well, so I do not have the nail. So let me check with this one. I'm pressing with this spoon. What am I doing is simply, I'm trying to reduce the space occupied by this one, so that when I keep into this water, it may sink. Let me check again. Oh, now it sank. You could see it here. It sank over there. Yeah, it's here now, isn't it? Yeah, it sank. So I'll show you this way now. That's it. Yeah, it's over here. It got stuck into this wall. So it sank. Same mass, but at first it floated, and in the second experiment it sank. The thing is related with the density. So the very simple conclusion that we can draw, if any substances that has density less than water will float, and any substances that has density more than water will sink. Very simple. This is in terms of density. But if we talk in terms of Archimedes principle, any substances, for example, I showed you that ship floated. The density of the ship is made in such a way that it is lesser than that of the water. Why? Because it occupied very large volume. We mentioned in that way. And next thing is that when it has more volume, high volume, the amount of water displaced by that ship, and when it is weighted, that results to the upthrust, which helps the ship to float. And suppose if the ship is of 1000 Newton, then the water displaced would be, of course, 1000 Newton. It won't be less than that. Suppose if the amount of displaced water is less than the weight of the ship, then the ship will sink. Because Archimedes principle says that if any object has to float, in that case, the weight of the object should displace liquid or fluid equal to its weight. We are very clear on this one. So we stated here two principles. One is the principle of flotation. Next is the Archimedes principle. I think we are very clear on these two things. And similarly, I gave you a few concepts on density, mass, and volume. Now let's speak some more things. So, I got an egg dipped inside. Now, Sandeep sir, do you have any idea? I've got, this is iron, salt over here. Suppose this egg has to be floated. I wanted this egg to float. What can I do now? Very simple. Just put your hand and take it up. Okay. It's not in that way. Let's experiment this one. So over here, I'll put some salt. Why? When you keep salt into the water, it will increase the density of the water. This is pure water, so I'm keeping some salt into it. So let's stir it now. I could have used warm water so that it could dissolve very quickly. I am not having warm water. Let's try in this way then. I kept salt into it. I'm stirring it so that it would dissolve. The salt get dissolved into the water. Do we have another egg? No? Okay, we don't have another egg. So I need to pick up this egg then. So this is salty water. I'm picking up this glass. I'm throwing the water now, just to get the egg. So what do you think? Does it sink or does it float? Okay, let's try. We can see it floated. It's upstairs there. It's on to the same level. You could see it, isn't it? Yeah, you can make a close shot, sir. It floated. This one floated. The egg floated. What is the reason? Now the reason is very simple. When we added salt into this one, the density of salty water is higher than the density of the egg, which resulted in the flotation of the egg. So one thing is very clear. When the density of the object is less than the fluid, it floats. And when the density of the object is more than the fluid, it sinks. Now in this case, it was water only. It has less density than that of the egg, so it sank. But in this case, the density of the liquid was higher than the density of the egg, so it floated. To try again, it floated. So this is very, very simple experiment that we did. Now let me go with another very interesting experiment. So we have got just one liquid. Now let me try with 2 or 3 different types of liquids. So I've got a medicine, in fact. This is a syrup. I bought the medicine. This is paracetamol. It's expired one, that's why I can use it. So this is also a fluid. Let's check what would happen. Can I pour over here then? I kept a liquid into it. I need water. I've got water over here. So what do you think? Water will stay above this red syrup zone, or it will go below the red syrup zone? Let's check. Okay, what happens, sir? Your water is above. What does it prove now? It proves water has less density than this paracetamol, right? Water has less density than the paracetamol. I've got another thing as well. I brought this. It's used in the kitchen, oil. Let me check this one. Okay, can you make a close shot so that everyone can see it? Okay, I'm not wasting much amount of the oil. So we got 3 layers now. Very clearly 3 layers, no? This bottom one is, let me remove all of these things now. Just clearing it. This bottom one is the paracetamol. This paracetamol, I use it. This is the expired one, so I can use it. No worries. The second layer is the water. And this third one, top one, is the oil. Now guess, from this one we can arise few questions. Which one out of these 3 has the highest density? This medicine syrup, water, or oil? Which one has the highest density? Right, the answer is this paracetamol syrup. That's why it's at the bottom. And which one has the least density? This is oil, in fact. Okay, I brought oil into it. This is at the upper position. Now let's check few substances. I've got this one. This I got, you call it supari. Supari के भन्छ? जे भेट्यो मैले त्यही ल्याएँ, यहाँ वरपर भेटेको चीजहरु I brought it, so I want to test it now. What happens if I keep supari into it? Shall we try? Okay, this is supari. What do you call supari for English? I don't know. Okay, sorry. I'm not good in English, in fact. Okay, let me check it. Oh, it floated above the syrup. Isn't it, sir? So what does it prove? That supari has higher density than the oil. Supari has higher density than the water, but supari has less density than the syrup, than this medicine. Clear? Okay, I have got this water bottle as well. It's cap, water bottle cap. Let's check of this one, right? Can I dip it now? Let's check it, okay? Just to make sure that it's not like a boat. So it's floating. What happened to it? It floated into the water, isn't it? It dipped into the oil, but it floated into the water. Can you make a closer shot? It would be much more clear. See, it floated into the water. What does it prove? That cap, yeah, cap, you can see there. Can you make the whole glass? Just show the whole glass. Oh, thank you very much. Oh, I have one more thing. This is what you call packing foam. Let's check off this one then. I'm keeping the foam over here. Right, let's check. Oh, it did not sink at all. It's at the top. It's at the top. Now the question. 3 liquids, 3 substances, and on 3 different levels. We can raise the questions. 3 liquids. First, this one is the medicine. This is paracetamol, I showed you. The second level is the water, and the third one is the oil. And similarly, I kept 3 substances over there. The top over here is the foam, and the second one, this blue one, is the cap of the bottle. Sorry. And this down one was supari. What do you call supari? Sorry, I could not say in English. Supari. Let me try a piece of stone. Do we have stone? No, I don't have stone. So let's have a short break now. I think that would be better, so that I can find a small piece of stone around. Meanwhile, think, why did it happen in this way? Can we take a short break now? Thank you very much. Okay, welcome back. I could just find a small piece of pebble. Let's check for this one then. And even we can go with this foil also. We had squeezed this aluminum foil, and we can check. Can you make a closer look now? So I've got this aluminum foil, and I've got a small pebble as well. So the small stone, I'm keeping it over here. Let's check what would happen. And that stone, it's sinking. Yeah, finally it sank. You could see it. Is it visible there? I'll show you this one. Okay, it's here. The stone sank over here. There's all 3 liquids. This is the stone, you could see there. And this is supari, bitter, something like, I don't know. Okay, water and all those forms. Now we can explain why it happened in that way. Let's start thinking now. So at the topmost level we have the form. So we have got 1, 2, 3, 4, 5, 6, 7 items into this class. Which one has the lightest density, least density? The answer of course is this white form. Answer of course is the white form. That's why it is at the top. There are 3 liquids. This red color is the medicine paracetamol, this colorless is the water, and this top one is the oil. Out of these 3 liquids, which one has the least density? So the answer is oil. That's why it is at the top. Oil has the least density. It's very clear, right? Out of these 3, water is moderate. So water has more density than the oil, and water has less density than this paracetamol. It's very clear. And the next one, we have a cap there, bottle cap. What about the bottle cap then? So this bottle cap has higher density than the oil because it sank into the oil, but it has less density than the water. That's why it's floating in the water. That's why it's floating in the water. We could see it clearly, right? And next, supari is there. I got supari, so I brought it. I could still not find out the English name for supari. Sandeep sir, can't you help me? Okay, supari. त्यो बिहा गर्दाखेरि बिहाको बेलामा सुपारी दिन्छ नि, त्यही सुपारी जे भेट्यो मैले त्यही ल्याइरहेको छु. ओके, सुपारी राखेको छु. ओके, एनिवेज नेपाली हो, हामी बुझिहाल्छौँ. अब यो सुपारी चाहिँ किन यो मेडिसिन सिरपमा डुबेन भन्दाखेरि इट हेज लेस डेन्सिटी देन द सिरप. अनि मैले ढुङ्गा खसालेर हेरेँ, ढुङ्गा चाहिँ सबभन्दा मुनि खस्यो. नाउ इट्स भेरी क्लियर. अब यति बुझिसकेपछि हामीले डेन्सिटीको कुरा गर्यौं, हामीले ल अफ फ्लोटेसनको कुरा गर्यौं, हामीले आर्किमिडीज प्रिन्सिपलको कुराहरु पनि गर्यौं. अब कन्क्लुड गर्दै जाउँ. केही कुराहरु कन्क्लुड गरौँ, त्यसपछि आजको क्लासलाई हामी यही टुङ्ग्याउँछौँ. त्यो भन्दा अगाडि एकैछिन हामी ब्रेक लिन्छौँ. एकैछिन ब्रेक. Okay, let's be back now. Okay, from this experiment now we are very clear about the densities of the liquids, densities of the object, and we can compare the densities of 2 things that is called as the relative density as well. So we are very clear with the word relative density, and if we need to measure the density of the liquid, then there is a device known as the hydrometer as well. So if we need to measure the density of the milk, then the device is known as the lactometer. And hydrometer is the device used to measure the density of any liquids. So that is what we said. Now with this note, let's recap few of the things. I posed you one question: which one is heavy, 1 kg iron or 1 kg cotton? The answer was equal. 1 kg mass is same, right? But if you look at the volume, iron is small space, whereas cotton is very big space. That means cotton has very high volume compared to the iron. So the number of matters contained in the 1 kg iron and 1 kg cotton is same. But if you look at the volume of cotton is very high, which means the density of cotton is less and the density of iron is high. Now we told that, I mentioned you that density is one of the prime factor to observe regarding the sinking or floating of the objects. One very simple formula is that If the density of the object is higher than the density of the liquids, it will sink. And if the density of the objects is less than the density of the liquids or fluids, it will float. But we told you that in Archimedes Principle, even the objects that has in general higher density than that of the liquid can float. For example, ships. How could it happen? We pose the question to you, and we said that the ship is designed in such a way that it has more space, more volume. As a result, the density would be less, and moreover, the amount of water displaced by that ship would be equal to the amount of its weight. That's why the upthrust would be equal, so it can float. These are the few things that we discussed today. Few questions to pose you again. If it is so, very simple question now. These are very simple questions that I could ask you now. The same iron nail will sink into the water, but ship made of iron float into the water. Why? With this note, we complete today's session. But before we complete, let me tell you once again, this session is not talking about the contents, knowledge section. It's just about arising some questions to the brain, just triggering the mind with some curiosity and imagination. Let's have experiments like this and try to figure out some of the knowledge, try to extract the knowledge and make ourselves a self-guided learner. And there is one saying, if hard work is the only thing, then all those donkeys could have become a genius. So hard work is not only thing. So it's creation, it's research, it's problem solving, and overall it's 21st century skill. Hope all of you will understand that and become a self-guided learner. Thank you very much. Thank you everyone. See you all. Bye-bye.